Welcome back to Learning with Merit. Today we're going to talk about Python conditionals. So covered in this video, we are going to review Booleans, relational operators, and logical operators. We're going to look at Boolean expressions, if statements, the indentation and the code blocks with those, if-else statements, chain conditionals, and nested conditionals. All of these things go together. First things first, let's take a look at our review. We've got several things to review here. First of all, conditionals often utilize Booleans, relational operators, and logical operators in order to work. So our Booleans are our true and false values. Relational operators are going to be our inequalities. So they are used for comparisons, and they always evaluate to a Boolean, which is a true or false. Here we have an example of each of the different operators we can use. So we have greater than, less than, greater than or equal to, less than or equal to, two equal signs, which we call equals equals, which is equal to, that is a comparison, not an assignment. If we use a single equals, that's an assignment. Then we have exclamation point equals, which is not equal to. So we can use all of those different comparison operators. We have some special things in Python that you may not have noticed in a math class. We have is, which is to check if two things are identical to each other. We have is not to see if they're not identical. We have in to see if something is a part of something else. And then we have not in to see if it's not a part of something else. Our logical operators, these are for multiple conditions, and this is a simplified sort of truth table right next to them that I'll explain. We have the AND operator. So true and true will yield true. Everything else will be false. So that's true and false and true, and false will all be false for an AND operator. Or false is the only time an OR is false. If you have at least one true, then it is true in an OR operator. An XOR, or exclusive OR, is where we have a true or a false. It must have one and the other. So only one must be true, but not both. Okay? So false and false would be false, and true would be false for an exclusive OR. And then we have not, which you can just think of as the opposite. So if it is not true, it is false, and if it is not false, it is true. It is that simple. Truth tables show how logical operators are evaluated, and I have simplified those truth tables here to the right. I covered truth tables in another video called Operators. So that is our quick review. Remember, we are going to use Booleans, we are going to use relational operators, we are going to use logical operators with our if statements. Let's talk about Boolean expressions now. So Boolean expressions are going to evaluate to true or false. That is how they work. So for example, let's take a look at one type of Boolean expression. We call this a string comparison. So here I'm printing out, and I say text equals text. So I'm comparing two pieces of text. Is this one equal to this one over here? And it should return true for us. So if I print that out, it will return true. We also might have number comparisons that we do. Again, using those relational operators. So here we have 5 is greater than or equal to 2. That is also true. So we would get that printed out. We're not going to print 5 greater than equal to 2. We're going to print true. We're not going to print text equals text. We're going to print true for that one. We've also got variable comparisons. So you can also use variables in order to compare. So if x equals some text and y equals other text, then we print x equals y, we would get false because those two things are not the same. So often you're going to see string comparisons, number comparisons, and then of course us using variables to compare numbers and strings and anything in between. A few examples for us we're going to take and look at over in our test file. So here you can see I have created some variables, a equals 1, b equals 2, c equals 3, d equals text, and equals true. And I'm going to add some print statements here with some Boolean expressions. So the first one is 5 is greater than 2. That is true. That uses actual literal integer values. Then we have print true and false. This uses two literal Boolean values, true and false, and requires both things to be true. Since one of them is false, we get false back. Here I've printed a equals b. We should also get false. A is 1, b is 2. Those two things are not equal. Line 18, we have a equals 1. It does, that's true. And b is greater than 0. B is greater than 0, so we get true because we get true here and true here. Then we have c is less than or equal to 4. Let's see if that's true. It is. It is less than or equal to 4. And so since one thing is true, I don't even have to look at the second one. For an or to be true, only one must be true. So we get true out. Then we have d equals text. It does, so we get true back. And the last one, we can take a look at this. E and b is less than a. Well, since a is a Boolean value of its own, we don't have to do any comparison there. We can just say true and is b less than a. It's not. Since both things must be true for an and, we get false out. So we got true, false, false, 3 trues and a false, and that's exactly what we have written there. So those are our Boolean expressions. They're simple. There are plenty more that we could come up with, literally an infinite number, but that's what they're for. They are going to evaluate true or false, and we're going to be able to use that inside of our if statements. So here we come down. Let's talk about an if statement and its syntax. So syntax is the way that you write a language, for example. So like English has its own syntax, so does every programming language. So if statements. We are going to start with the word if, and then in parentheses next to it we have some condition, and then we end with a colon. The condition is always in parentheses and is a Boolean expression. Then we indent 2 spaces to be inside of the if code block, and we unindent to be outside of the if code block. Here's another way for us to look at this. So here we have the entire block, right? We've used different little symbols here to show that this is the entire block. Then inside here, this is our if. This is going to run when the condition is true. So this block runs when the condition is true, but it's skipped when the condition is false. Each new if is its own separate conditional. So this if is checked, and then this if is checked because they are separate conditionals. So if this is true, we run this block, and because it's true, we run the block. If it's false, we skip the block. It's as simple as that. Here's an example that we can use in our test file. So sky is equal to blue. We check if sky equals blue. Since it does, this is true. It evaluates true. Then we print the sky is blue. Let's save, hit run, we get the sky is blue. Let's change it to literally anything else. Let's make sky black. When I do that, it skips the code and moves on. Another example. It's example 2 here. This time we have day equals true and time equals 12. So if it's daytime, so if day is true, and time is equal to 12, it is. Since day is true and time equals 12, that's also true. True and true gives us true. So the whole thing evaluates true, and we get it is noon. Let's run that. Whoops. Save again, make sure everything's good. and we get it is noon. If I were to change this, let's say it's 3, then our Boolean expression here would evaluate false because time is not equal to 12. Make sure we're saved, and you see we get no output. Let's talk about if-else statements. If-else statements allow us to make a quick decision. So now that we can make one type of decision, now maybe we need to do something else if the decision is false. So in an if-else statement, here is our whole code block. They go together, but they also have their own separate pieces. So we have the if part, which we already know about. We write if, open and close parentheses, colon. In the parentheses, we have a condition, which is a Boolean expression. Then we run the block if it's true. We skip the block if it's false. The else block only runs when everything above it is false. So if this condition is false, the else block should run. If this condition is true and it runs this block, it skips the else. And that's what it's talking about right here inside these little blocks. And you'll see that we've added little symbols to help us understand how it's blocked out. Remember, we have to indent to be inside the block and unindent to leave the block. A few more examples. Here we have two separate little if-elses. So if true, we're going to run this block. Else, we skip that block. That's because this is true. So this is true, we ran that block. Then we come down here because we're in a new if, and we say if false. Well, we skip that one because it's false. And then we run the else because everything above it is false. A couple of examples we can look at. So we go to our test file here. Here's one example. So we've created a variable called switch and we've set it to 1. If switch equals 1, then we say the switch is on. Else we say the switch is off. We print those out. So right now we see the switch is on in our output. If I change this to 0, save it and rerun it, we see the switch is off. So now we have a way to alternate between two different things based on what the value of this variable is. And that can be very useful, just like a switch. Another example we could use. Let's say we're trying to figure out something like bedtime. This could be really useful for like an alarm clock, for example. So here we have time equals 12, and that could be different values that update over time. But we say if, and we check if time is greater than or equal to 22. That's military time because computer needs different times. We can't say 10 and 10. So 22 would be 10 o'clock p.m. So if it is equal to 10 or later, or our time is equal to 6 or before, we print go to bed. Otherwise, we need to wake up. So right now, because it's 12, it should print wake up. And it does. But if we make the time, let's make it 3 o'clock in the morning, it's time to go to bed. So it says go to bed. We got another example. A third example. Here we have number is equal to 5, and this is our even and odd example. So in order to figure out if a number is even or odd, we take the number, we divide it by 2, but this right here is a percent symbol. That's for modulo, or the remainder. So 5 divided by 2 gives us a remainder of 1. Since it doesn't equal 0, we skip this code and we print odd, because 5 is an odd number. So we get odd. But if we put 6 there instead, we get even, because 6 divided by 2 has a remainder of 0, because 2 goes evenly into the number 6 3 times. So just another example of how we might use that. Now let's talk about chained conditionals. We're getting more and more complicated as we go. A chained conditional is going to look something like this. So a chained conditional will have an if, then a condition, an elif, then a condition, then an else. And this is fairly simple. So an if runs if the condition is true, it skips if it's false. An elif runs if its condition is true and the ones above it are false. And it skips if its condition is false or one of the above is true. So if this one is true, this one won't ever run. But if this one is false, this one will run if it's true. And then the else, just like last time, only runs when everything above it is false. So here are some examples of different things, just very simply. So here we have, if true, run this block. And it does. Because this condition is true, it runs this block and skips this one and skips this one. This one is false, so if false, we're going to skip this block. This one's true, so we run this one and skip this one. The last one, this one is false and this one is false, so we run this block at the end. A couple of examples we can look at. This would be a chained conditional statement. So here we have direction equals north. So if direction equals north, we say going north. If it's not north, we check if it's going east. If it's not east, we check if it's going south. If it's not south, we check if it's going west. And if it's none of those, we give an error. We print out error. So let's look at this first. So this time, it should print out going north. And it does. Let's change it to a different one. Going east. So it's going to check north first. Since it's not, then it's going to go down to the next one and check if it's east. It says going east. We can change it to south. Same thing. It's going to check the first one. It's false. Check the second one. It's false. The third one is true, so it runs it, skips everything else. Oops, did I make sure to save? Try it again. Going south. There we go. Let's say I just put some gobbledygook in here. That's what the last one's for. So north, east, south, and west would all be false, so it's going to print the last one, the else. Prints error. You'll notice every time I'm indenting 2 spaces to indicate the block that should run. And see, we get error that time because we've got a bunch of gobbledygook as direction. So now let's look at nested conditionals. Nested conditionals can be kind of confusing because they seem very strange. So nested conditionals are going to be conditionals inside of conditionals. So this can happen whenever I need to make a decision after I've already made another one. And I have a really good example for this that ought to help you understand. So we have if this is true, then we come down here and we check if this is true. So you'll notice I've indented 2 spaces. That's because this if is inside of this if. And then down here, I've also indented 2 spaces. So this block only runs if both of these ifs are true. It checks the first one. If it's true, then it checks the second one. Then it runs the code. There are so many different combinations with nested conditionals, I couldn't show you all of them, but I am going to show you a good example. So here, if we look at this, let's say I have goals like in a video game, for example. So here I have goal equals true, goal 2 equals true, goal 3 equals false. And I'm going to change that to true for right now, just so that we can see. So here I have this big, long, nested conditional. And I have it separated into blocks. And you'll see these lines right here that go down. So this if goes with this else. And you can see the line to help you indicate where it's at. This if goes with this else. This if goes with this else. So here's what happens. It checks if goal 1 is true. If it is, it prints you reached goal 1. Then it checks if goal 2 is true. If it is, it prints reached goal 2. Then it checks if goal 3 is true. If it is, you reached goal 3. But you can only reach goal 3 if you reached goal 1 and 2 beforehand. So since all 3 are true right now, we see reached goal 1, reached goal 2, and reached goal 3. Now let's slowly change it all the way back. So goal 3 is false now. So it's going to check. It says, is goal 1 true? It is. So it prints reached goal 1. Then it comes down here. Again, we notice we indented. Goal 2, is it true? It is. So it prints as reached goal 2. Then it checks if goal 3. Well, goal 3 is false. So it says missed goal 3 instead, because that's the else block there. So let's see when we run it. Clear everything, and it says missed goal 3. Should I save? So reached goal 1, reached goal 2, missed goal 3. Now let's see what happens whenever goal 2 is false and goal 3 is false. So we change both of those. We go through and check, and it says, all right, goal 1 is true, so it prints reached goal 1. Goal 2 is false, so it comes down here to this else and prints missed goal 2. It won't print missed goal 3 because we never got there. So I save, I hit run, see if it throws an error. Save again, clear our code. There we go. Reached goal 1, missed goal 2. That's exactly what we expected. So let's make goal 1 false now. So now what will happen is it'll check goal 1. Since it's false, it comes all the way down here to this else and then prints no goal reached because we didn't reach any of the goals. And you see no goal reached just like that. So this is the power of a nested conditional. I only check goal 2 if I reached goal 1, and I only check goal 3 if I reached goal 2. All right, we stick them inside of each other so that we check one after the other as needed. So nested conditionals, they can be kind of confusing, but it depends on exactly what you're trying to do, and there are so many different possibilities. For example, we could have an if inside of an if inside of an if, and then maybe we have an else with that. Maybe we have an if, and then we have an if, elif, else. So it just depends on the problem, but you can stick one condition inside of another, and that allows you to make multiple checks until you get the answer you need. There are so many different possibilities with conditionals. So what did we talk about? We did a little bit of review of Booleans and relational operators. We talked about Boolean expressions. We talked about if statements. You have an if statement. It allows you to make a decision using a condition, which is a Boolean expression, and then you write the code block. We talked about Python indentation in these code blocks. So after I write an if, I need to have an indent of 2 spaces. We talked about the if-else statement. So we come down here, we find the if-else statement. We run the else if the if is false. We talked about chained conditional statements. So we run if the stuff above is false. So we check the first one. If it's false, then we check the second one. If it's false, then we run the last one, for example. And then if one of these is false, we run it and move on. Each new if is its own new block. So every time we start a new if, we have a new block of if statements that we need to work with. So a bunch of different examples there. Then we talked about nested conditionals. Nested conditionals allow us to put all of these things together inside of each other in all the different many combinations that you can get. So hopefully you learned something there, and thank you for watching.